Hello everyone. Good morning and good evening. This is your ALP here. Welcome to ALP Talks YouTube channel. So we'll be reviewing many electrical and electronics related textbooks. We'll be reviewing those things, and also we'll be discussing about the topics the particular textbook is going to cover. So here we are starting with electrical circuit analysis. So initially we are focusing on most easy textbooks where we can easily understand it, the terminology and everything. And later on, we will go for reference books as well as little bit advanced books for R&D and other aspects. So here you can see this is the electrical circuit analysis, and you can see the author is Bakshi. So these are these very simple books, you can say. Okay, very simple books. So you will find multiple books with this author on different electrical and electronics topics. Here we have 8 chapters, and you can see here the first is like basics of electrical circuit analysis, mesh and node analysis. It's like I can see introduction, circuit elements, RLC elements, and the voltage relationships between resistance, inductor, and capacitors, like V code IR, like that. And energy sources, voltage source, current source, and there can be sometimes dependent sources also, like we can see in electronic components like transistors and all. And Ohm's law we'll be discussing, and electrical work, electric power, energy. These are the basic terminology. If you see about a network, what is meant by network, element, branch, junction, point, node, mesh, loop. These are the basic terminology we'll be discussing on. And also a classification of electrical networks, and also analysis. There would be series and parallel branches based on current and voltage relations. And also we will have Kirchhoff laws, like current law and voltage law. So this also we'll be discussing. And sign convention. We have to follow certain sign conventions while applying Kirchhoff voltage law for a closed path. And Kirchhoff current law we will apply for any particular nodal analysis. And also we will be seeing like voltage division in series circuit and the current division in the parallel circuits with simple resistances. So, and also we will see like what is that resultant of resistances are connected in series or parallel. And when we want to transfer source from voltage to current, current to source, we will see that. And also like source shifting, voltage source shifting, current source shifting, and the concept of loop current. So that also we will see. And finally, like loop analysis or mesh analysis. So there may be a number of small meshes. We will be assuming certain current in the loop, and we are going to calculate it by using basic mathematics. And we will have super mesh concept also, and steps for loop analysis. And next one is like a nodal analysis. We'll assume certain voltage at each node, and we'll be doing analysis like I equal to V by R. V is the nodal voltage. Resistances we have to consider of each branch. And if you see super node, and we have some steps for nodal analysis. And at the end of the chapter, we'll have some questions and answers also. That gives a boost for us. Similarly, we will have certain theorems are there in the network. Theorems will be there, like on duality. So those theorems are required. They are the basic concepts which required for us to solve many electrical circuit problems, like superposition theorem. We'll be explaining what is superposition theorem, and what are the different steps we have to apply. And we are applying like Thevenin's theorem. So we will be calculating voltage and resistance, V and RTH. Total along the source, across the source, we can say total how much resistance is there, equivalent we will be calculating. And there will be certain limitations for everything that also we'll be discussing. Next one is Norton's theorem, we can say like current related. We'll be discussing about this Norton's theorem also. And maximum power transfer theorem. There are certain cases where maximum power we have to transfer from source to load. There would be certain conditions. We'll be discussing that. And we have a reciprocity theorem and a compensation theorem. These are the circuit analysis. These are required. And we have duality also. So how to construct dual networks, mathematical methods, graphical methods, we'll be discussing in this chapter. And the next one is like a solution of first and second order. There would be, it's like a differential equations. Okay. So there would be first order differential equations means It's like V equal to IR plus LDI by dt, like small resistance and inductive network. And another case, small resistor or capacitive network. So those things will be there. And if you go a little bit further in second order equations, both RLC elements will be there. That we will be discussing. And here we'll be having certain initial conditions in basic passive elements. Like we will say RLC elements as passive element, resistor, inductor, capacitor. There will be certain charge in the capacitor. There will be certain initial current in the inductor. Of course, for resistor, nothing will be there. Okay, this we will be discussing. And homogeneous, non-homogeneous, those things we will be discussing. Of course, here, basic mathematical equations also we will be discussing for a while. If you see here, transient response of RL circuit, for example, when DC excitation is given, how the circuit behaves. Okay, and when R for same thing for RC circuit, when DC excitation is given, how the circuit behaves. And we'll go for a transient response for a second order equation. Like we told RLC circuit, three elements will be there. We can say in another way, like 1 plus 1 by S plus S, R plus, we can C by S plus LS. So that is another way we can calculate these differential equations. And we'll have some steady state analysis also with sinusoidal steady state analysis. We will have different alternating quantities, right? Basically, electrical circuit or electricity we are generating in sinusoidal way or sinusoidal form. So sine wave is the majorly we will be using at all the places in electrical network. So how to quantify it? Instantaneous values, RMS values, average value, maximum value, or peak value we can say, and certain factors will be there, the form factor, and we'll be calculating averages. It is not only limited to sinusoidal, but we have to focus on some other like trapezoidal waveform is there, current generation, or triangular waveform is there, a rectangular waveform is there, sinus or a square type of pulses are there. These are quite common in power electronics and electronic circuits, where triggering is there or where DC conversions are there. Those are quite natural. We'll be discussing those things. And also phasor diagram. So these all sinusoidal things are not normal numbers. They are associated with magnitude and angle. Okay, it's like complex summation. R and theta will be there. R comma theta. So phase and phase difference. Mathematical presentation. Polar coordinates are there. Rectangular coordinates are there. And how to convert polar to x. For example, if it's say x plus jy, j is the complex number, complex indication, we will say a plus ib, like that. If you want to convert into polar coordinates, r comma theta. R is the magnitude, theta is phase angle, tan inverse y by x. Like that, we will be seeing all the detailed things. Okay. And if it is pure capacitance, pure inductance, and pure resistance, what is the case? And impedance. Impedance is nothing but square root of resistance plus reactance square. Reactance means it can be capacitive reactance or inductive. We will be seeing power factor, power triangle, power factor improvement, and different circuits. For example, if XL is more, if XC is more, both are equal. We will be seeing about resonance also here. And if you're working for parallel circuits, we can see like admittance and other concepts. Okay, admittance triangle, mesh and nodal analysis we'll be using. And now the concept of three-phase system comes, where RYB will be there, or ABC phases are there. They are the voltages and power currents separated by an angle of 0, 120, and 240. Three-phase balanced system. In space, 360 degree are there. If you divide by 3, we will get 120 degree. Each are separated by 120 degree. How the summation will be there, how the resultant will be there, how they are connected with each other, like a star, delta connection, line currents, phase currents, if balanced load is there. And so we have certain things like power triangle, three-phase load, and also relations will be. And we have some question and answer also. And we have some coupled circuits. Whenever we will see, this is particularly very important for transformers when you're considering about transformers. For example, basic magnetic laws, whenever a current flows in a coil, there would be an EMF induced in it, right? Current flows, flux will be there, EMF will be induced. So when any another coil is there, there would be mutually induced EMF. So self-induced EMF, mutual induced EMF, And Faraday's laws of electromagnetic induction. This is not only for transformer, of course, for motors, generators, alternators, always these basic magnetic concepts will work. So here we are calculating series parallel combinations and linear transformer, ideal transformer. Some questions will be there. And if you see, this Laplace transformation is one of the best thing we can say to solve the circuit analysis easily. So if you see V equal to IR plus LdI by dt, if you apply Laplace transforms, we can do V equal to IR plus LS like that. So this is very good concept for easily doing calculation. We will be discussing about these Laplace transforms, advantages, linearity, scaling theorem, and the real integration, differentiation by S. That's what we discussed now. So whenever time is there, converting into f of t, and the phase shifting theorem, initial values, final value, time scaling, t is there, t by a, or at, something like that. And also there are certain standard sources like step function will be there, delayed step function will be there, ramp function will be there, delayed ramp function, impulse will be there, sine function will be there, cosine function will be there, exponentially damped sine and cosine function. So this will be there. And we'll be using convolution theorem. Convolution theorem. So integration of a dot b, if you convolute it, we will be getting in a different way. So we have convolution theorems, and we have inverse Laplace transforms. Simple roots are there, multiple roots are there, conjugate roots will be there. We'll be doing that. And also we have we did differential equations for RL, RC, RLC circuits with DC excitation. That means normal plane DC as well as sinusoidal AC excitation. And also we will be doing with examples with the zero initial conditions, by including some initial conditions, and also transfer function. So transfer function is our time domain response analysis, frequency domain analysis we'll be doing by using transfer functions. So here, finally, we have the concept of resonance as well as network function. Complete network we can represent like a black box. We can have input and output, input port and output port, and we can say like poles, zero, singularity, gain, pole zero plots. We'll be doing a kind of some of the things. And for quality related, some Q factor, figure of merits, particularly discuss about resonance. Okay, resonance will be there, reactance curves, series resonance, and LC, bandwidth and selectivity. If it is parallel resonance means anti-resonance, you can say. Those also will the work discusses. And finally, frequency response. So finally, so we can plot these kind of plots. What happens to if you are developing any system? What happens to the particular frequency? Like border plots, Nyquist plots. There are certain plots for us. We will be discussing about those plots. And the final chapter is network theorems, two-port network. There are different parameters we can represent an electrical network. For example, if you take transmission lines, we can represent by using these kind of parameters like ABCD parameters. Or if you take any transistors, we can use a hybrid or G parameters. Like that, we have different parameters, Z parameters, Y parameters, H parameters. We can represent it. So there are different conditions also, and the condition of reciprocity, and how to interconnect two different networks, series, parallel networks. Like that, the things will be there. If you see, the language would be very simple, very plain. You can see Ohm's law can be successfully applied to simple circuits, but for analyzing complex networks, advanced circuit analysis techniques are required. Whereas it is easy to read, resistance definitions are given, inductance definitions are given, capacitance you can see, RLC we covered here, basic what is meant by capacitance, those things we are covering, all summation we are covering here. We have, so you can see voltage source is there, some load is there. That is the characteristics we can plot with some graphs. Okay. So same thing here. There would be certain drooping characteristics also, ideally. So we may think, let's say battery is there, 12 volts is the voltage. But if you keep on increase the load, the voltage will decrease, right? 11.5, something like that. So that is the drooping characteristics. So you can see DC source are there. AC source means we will be representing like this. So these are the small examples. Okay. We have time variant sources, time invariant sources. So it won't depend with time. DC source, it won't depend with time. It is fixed magnitude, but AC will depend with time. We have voltage dependent source, current dependent source, current dependent voltage source, voltage dependent current source. The four varieties are there. And now the actual Ohm's law will be beginning. And electrical power. These are the basic terminology, okay, for any electrical engineering. Not only electrical, we can say this is BEE for any other electrical related to the branches, we can say electronic branch or other aeronautical or computer science also. It's better to deal these kind of chapters. So how power is there? Power is nothing but VI. So energy means I square R. You can see VIT. We can say time we will be adding for energy is considered, and network terminology. So if you consider small element, this network, how we can say some analysis like what we see in a mesh analysis, nodal analysis. These things we are discussing. Kirchhoff's law, current law, voltage law. Okay, these are the different laws we'll be discussing with this book. So many good examples are there. Okay, many good. So you can see these are the ways when any voltage source is there, what is the current flowing in another branch. So they will give some this is element and ask the element value. Like this, it will be there. So calculations, circuit analysis is based on purely mathematical concept. We have different topics here like voltage source shifting, and here you can see current source shifting. These are the different concepts. It is easy for university examinations also, as well as preparing for gate and other branches. They can use this concept. Loop current. So this is the loop current. For each loop, we will be considering certain current. That current we will use for solving the equations. Okay, we will apply mesh analysis. You see, this is the sign convention. Okay, starting you will take plus, ending will take minus. This is how we will be applying. If you have one loop, one equation will be there. If you have two loops, we will have two equations. So we can have it. Three loops means three equations we can draw, and we can calculate. You can see finally current we are calculating, and of course here directions also matters. Okay, so directions also matters. We have good examples for analyzing different concepts. So sometimes certain value of resistances also we will be asking to calculate, but we can do it once we calculated current and all. This is the nodal analysis. So we'll use the voltages at every node or junction, we can say. So we will be applying current. Total current at entering and at the leaving the junction is equal. Otherwise, all currents entering the junction should be 0, or all currents leaving the junction should be 0. We can follow any certain, this is how we can do I equal to V by R. We can follow certain rules and throughout the concept, and we can finalize it. Okay, so this is how different vectors are there, are different current calculations, voltage calculations, circuit analysis. We will be having small questions also. It gives some understanding for us. So you can see 1 kilowatt hour means this is the basic question. Many places we can be asked in interviews or any examinations. How many joules? Okay, you can see time is the only thing, right? If you're considering energy, time is the only thing. 1000 watts, 1000 watt hours. Hour means 3600 seconds. That's it. 3600 into 1000. 3.6 into 10 power 6 joules. So like this, it is very good book. Okay, you can go through this book. The sums and everything is very clear, very simple. Okay, so whatever the topics we discuss, that will be discussed in this book. It is easy to read. Do practice it. If you need any questions or if you need any support, you can ask. You can comment us. Okay. Of course, we will go for a detailed circuit analysis discussion also later on in the coming days. Okay. So you can see here we have different chapters here. We have model papers also, exam for examination. So basic questions are there. Okay, this is limited edition only. Thank you. Thanks for watching. If you have any feedback, do comment it. Thank you. Do subscribe to this channel for many more updates.